Okay, good afternoon, one and all. I welcome everyone to the fourth day of uh, our faculty development program titled Current Trends in Civil Engineering. Now, our honorary speaker is here with us, so I will take this privilege to give a brief introduction about Bibhas Bhowmik sir, who is going to give a expert talk today in this session. Now, Bibhas Bhowmik sir, he is a graduate from Jalpaiguri Government Engineering College, and he has his post graduation from IT Delhi with applied mechanics. Bibhas Bhowmik sir, he is an expert in oil and gas, power, seaport, aluminum plants, material handling facilities, and various civil infrastructures. Sir has got over 35 years of experience and is a technocrat in all the mentioned areas. Now, Bibhas Bhowmik sir, he provides his expertise, okay, in engineering, procurement, and construction companies in order to increase the profitability through strategic planning, tendering, and costing. Further, he also provides engineering design and techno commercial alignment. Sir has worked with operating oil companies, engineering consultants, and construction with major engineering projects costing more than about 2.5 billion US dollars. Sir has been associated in academia as well. He has been teaching industry oriented courses, and presently he is working as an independent engineering consultant and associated with various NITs and IITs, and also he is associated with different private engineering colleges in India in order to design few engineering courses, uh, particularly the modules for undergraduates and postgraduate students. And then he has also delivered several lectures covering the topic on practical challenges faced by industries. Now, sir has pioneered a scholarship. Okay, he has pioneered a scholarship chapter in his alma mater, that is Jalpaiguri Government Engineering College, wherein they render a help to the students who are in need. Now, this scholarship chapter, it has been started from 2013. Now, we are very much privileged and we are honored to have you, sir. So I welcome you and I welcome all of the participants. I will give the stage to Bibhas Bhowmik sir. Sir, welcome to you, sir.
Thank you, Professor Anup. 22nd of April 2021. We are a group of civil engineers here who are expert to build bridges mostly. I mean, bridge between academia and industry to synchronize the development of the most promising country of this century on earth, our own Mother India. We don't build high walls anymore like Great Wall of China or Vatican City to limit or segregate us from surrounding world. We are committed now to build bridges with a steady flow of knowledge and fieldwork experience under the great leadership of BMS Management Vision of Faculty Development Program. Let this legacy continue in true spirit. Good afternoon to all professors and if any student present here in this session. Let us start the positivity from the industry to influence the engineering challenges in industry. First slide, first few slides, I will just scroll through and then we will talk really why we are starting with this kind of industrial pictures. First slide is demonstrating a structure called flare stack. This is generally used in oil and gas sector to burn out the untreated oil and gas at higher altitudes so that there is no environmental pollution. So all of us are teachers here. We teach the civil engineering subjects to our students, but this is the real need of our where three subjects are to be punched in the civil engineering course. One is QA/QC, quality assurance, quality control, health, safety, environment, and contract management. That is why I have kept the title of today's topic, Civil Engineering Essence with QA/QC, HSE, and Contract Management Flavors. These are the current industry needs which civil engineers, when they're coming out of the campus boundary, they should be aware of, at least to some preliminary extent. Another picture in this slide is a huge hydrocarbon storage drums, which are really feedstock for a natural gas liquid plant. This is another slide. We can see on the left hand side, this is an oil and gas plant. This is natural gas to liquid plant, and a compressor house is getting erected by crane. The steel structures are getting erections. Right side,
Bibhas sir,
foundation. Yes, please.
sir, sorry to
Hello.
interrupt you. Sir, sorry to interrupt you. I think we are not able to see the slides.
Is it?
Yes, sir.
Sir, nobody
Very
told
clear.
me why. Why not? Because I was sharing it. Uh, okay, present now your entire screen. 1 second, sir.
Yes, sir. Yes, sir. No issues. Sorry for the
Yeah.
interruption.
No, it's okay. Without slides, how we can proceed? Good
Yeah.
that you have pointed it out. How we can proceed that the whole flavor of the session will go out. Sir,
Yes.
I'm surprised that why it is not, because I am presenting your entire screen. Fine, share. Is it visible, sir,
Uh,
now?
yeah. Just yes, sir. Now it is visible, sir.
Now it is visible. Right,
Yes.
sir. I will just uh, make it full screen. Is it visible, sir, in a better
Yes, sir.
way?
Yes. Yes, sir. Yes,
Now it
sir.
is visible, right?
Definitely. Yes,
Fantastic,
sir.
sir. Right.
Yeah.
So we
Thank you,
will
sir.
just quick. Yeah. No, it's fine, sir. Dr. Rajesh, absolutely fine. You could tell me much before. You could tell me much
Yes.
before. No problem, sir. So
Okay,
this is
sir.
the first slide. Where we are talking that flare stack erection. And the essence of today's discussion is civil engineering essence with QA/QC, quality assurance, quality control, health safety in environment, and contract management flavors. Why these three topics are very much important in today's world when an engineering graduate or postgraduate comes out of the institution. The left side, I will just start with few industrial slides and then we will speak about these three courses preliminary. The left, you can see a tall structure. I was involved in that right from the conception till erection and commissioning of this structure. This is called flare stack, where all the poisonous gases from an oil and gas plant are burned at a very higher altitude, not to pollute the environment. Right side is a picture where we are storing hydrocarbon in big drums in the oil and gas plant. This is a feedstock for a gas NGL, natural gas liquid. So we are transferring the gas to liquid in the NGL plants because it is easy to send through the tankers that these liquids, but which are actually natural gas. So these are the huge storage vessels which are generally kept in the plant for 3 to 4 days feedstock. Then second slide is a compressor house in an oil and gas plant, which is getting erected. Steel structures are just getting in place before cladding operation. And right side is the foundation of a particular leg of this structure. You can see it is a four-legged structure. So just foundation, and we can see here the reinforcement colors are green. Why green? I'm sure we will talk about all these things in the next slides and so on. This is another interesting slides in a seaport where we can see the pipe racks. All these heavy pipes are supported on the concrete or the steel frames, and the bridge, the pipe structural bridge in a jetty actually, where the pipes are crossing from one side of the road to another side of the road. We need bridges at quite elevated, in a quite elevated manner, so that transportation can continue without affecting the structure. And the jetty structure, you can see me there. So these are the industries where an engineer, when he or she comes out of the college, dreams always. But if they are given the basic flavors of these industries during the course outside the moment distribution, conjugate beam method, Williott-Moore diagram, Moore circle theory, and other uh, design subjects, what we learn during the college courses, I think the students will feel more interesting, and they will feel themselves that they are more attached to their future goals. So now, what are the ways we can make these engineering courses more interesting to the students? We'll start with preliminary version of QA/QC, what is quality control and quality assurance. The first slide says that whenever starting a project, we must have a project quality plan. You see, what is project quality plan? In any project of infrastructure or any industry, we must select and approve the major subcontractors or sub-vendors. What are the process to approve a subcontractor in a particular project? Suppose there is a project of a multi-storied building. We cannot include a subcontractor or a vendor in that project who is having an experience to build swimming pools. So what are the selection process, approval process in the project quality plan? Those are the things which we write in the PQP, we say in the short term in the industry. Now, approval of drawings, design data, calculations, test procedures before proceeding with the relevant activity, and maintaining sequential submission of engineering deliverables. I am reiterating the words sequential submission of engineering deliverables. In a plant, we are doing the design as a civil engineer of a pump foundation. But if the pump capacity, pump loading, natural frequency, starting frequency, or running operating frequency of a pump is not finalized before starting the design of the pump foundation, is it meaningful to the engineers? No. But these are the things project quality plan assures, that we should not step the jump of engineering process in the industry. So first, we should, as a civil engineer, we should know what are the data we need to do the design of a pump foundation, and which are the data to be frozen first before starting the design of a pump foundation or a crane girder. So these are the salient points which an engineer should know before joining an industries: how to approve a drawing, how to approve a design data, what is the process of approval of a calculation document, what are the test procedures at site. Third bullet is process for ensuring the correct uses of the drawings, specifications, procedures, etc. during manufacture, fabrication, testing, installation, mechanical completion, and pre-commissioning as applicable. So what are the terms of mechanical completion? What is the terminology in pre-commissioning? These are the things which are very important for an engineer to know basic terminologies before joining an industry. Why I am saying the correct use of drawings and specifications. Suppose we are building a tall steel structural building or a concrete frame building in a locality. So what are the specifications involved, or what are the basic design basis for doing the design of a tall residential building. Those are very important to know that in this particular tall building, should we keep the provision of a helipad? What are the fire escape routes? So what should be the civil structural design basis? Should we consider here the earthquake or not? So the design basis and what are the specifications, structural steel specifications, concrete specifications, site preparation specifications, anchor bolt specifications. There are so many things which an engineer should know when they are doing a final year project. I have interacted with few colleges and I have seen last time also the students of BMS are really very intelligent. They asked me very tricky questions. So this is a thing which we should follow in the final semester when they are choosing a project as a final year project in undergraduate course, or whenever they are choosing a project in PG course, a thesis. Suppose we are working in an oil and gas plant, which is a highly inflammable plant. Any gas storage tank or any liquid storage tank or any equipment might get blast. So in those blasts, in case of those blast incidents, how the people inside the control room should remain safe and they should switch off the plant step by step. Those are the things we should know in a blast resistant structural design in a control room. So what are the salient features in a to be considered in a blast resistant structure? Those an engineer should know, or he or she can do this kind of thesis or project in an engineering college before joining the industry. So we, as their future guardian, we should interact with each and every student, understand that what is their inclination to join what kind of industry, and accordingly select a project or thesis topic to make them more employable in those type of industry or to increase their employability rate. That is where the vision works in this industry right now. I have taught in UK and I have seen that the students there, how tuned they are during their engineering courses with the industry practices. This we are really lacking, and we have reached the high time to bridge this gap, and we must act together to bridge this gap in such a way so that these students are really an asset to an industry when they join. Now, organizational chart. What is vendor? What is subcontractor? Who is the main contractor? This kind of organization chart, they should know through the quality management system. Now, we are coming to the quality assurance, document and data control. When a design document is ready, if somebody is originating a design, that should be verified by another engineer, little bit experienced, and finally it should be approved by the chief engineer. So this is the way documents, how those are getting handled in an office properly. And data control. Suppose I have designed a pump foundation with some preliminary data, and during ordering of that pump, every data sheet or pump design frequencies, pump weight has been changed. Whereas my design, civil foundation design, is done based on the old data. So how these data are getting controlled in an organization so that correct drawing reaches to the site for construction. These are the things the civil engineers should know before joining the industry. Purchasing process, when they are purchasing raw material for the civil and structure, how we should do the bid tabulation. Suppose I am doing the purchase work for structural steel in a factory. How I should process the purchasing of the raw structural steel material, I section, channel sections, angles, bolts, and some other nuts, some other issues, some fasteners as well. What should be the process, and how these bid from different vendors should be tabulated properly as per the specification. These are the things which we should impose to the students before they join the industries. Inspection and testing process, we will talk about it later, how the inspection is happening in an industry and how we are testing the materials. Control of non-conforming product. What is non-conforming product? Suppose you have designed a connections with 20 millimeter diameter bolt, but the erector or the contractor has used 16 diameter bolt in that connections, and that in future the connection will fail due to the less size of bolts. It is very difficult to judge all these things from far. So how we can control this kind of non-conforming product in a systematic manner, those things, how we should handle storage and packaging and the delivery. Suppose from a factory, fabrication is over, and then I am delivering that item to a site which is a 50 kilometer away. How it should be packaged, how it should be delivered, those things, basics, an engineer should know before jumping to the industry. Quality records, how we maintain the quality records at site for different concrete batches which are getting produced in the batching plant. Training and audits, how we are training the junior engineers, how we are training the interns, then how the audit happens in the technical departments, quality document submissions, requirements, and quality management systems. Now we are straight away going to an ITP, inspection and test plan. We were just discussing here in this slide inspection and testing process. I'm just giving an example of a particular concrete testing procedures. While we are doing concreting at site, there may be so many 10 types of tests, you can see it here. But now we will discuss only type 8 in the further slides, concrete batching plant inspection. That is the mother source of concrete at site. Suppose there is a huge plant, and in 7 or 8 places I am doing concreting in one day. Now it is getting controlled from one batching plant or several batching plants, and how the concrete is getting prepared there, how it is reaching to the pouring site, and after pouring what is happening. If we are not maintaining these records, even if we are very good designers, very good teachers teaching students within the classroom, your students are doing fantastic design in pen and paper or through computer, but finally what is happening at site, that is different. Then the essence of doing the right design, learning the right engineering practices within the classroom goes into the waste, sir and madam. So we have to be very careful to teach the basics to our students, how we can keep this kind of quality at site. Now this is the batching plant, how we can, this is what I am trying to say, only one ITP item, inspection and test procedures. I have developed a complete course of this QA/QC and HSE management. This I am just trying to give you a little glimpse that how we can attack one by one all these things in a proper course and make a student very much careful before joining the industry. So in a batching plant, you see, this is must guidelines on a mandatory requirement in batching plant during hot weather. Suppose we are doing concreting in Rajasthan or in some places of Gujarat, which gets very hot and humid during that summer, or we are doing a concreting in a very close to zero temperature in Srinagar. What are the things I have given here? ACI reference, it is American Concrete Institute reference, but we have equivalent Indian Standard Code, while we will understand that during the design of a batching plant, what are the basic requirements we should know. Every batching plant used in site should be approved by client. Field trial for each concrete mix shall be carried out in every batching plant used in site. Field trial of each concrete mix, I mean to say every time one batching plant is producing a concrete mix, every trial sample should be analyzed at site. Aggregate storage area, how the storage area should be, that should be covered or uncovered. Partition wall between different size of aggregates. Suppose some places we are using 20 millimeter down, some places we are using 30 millimeter down aggregates for making concreting in the batching plant. So how we can segregate it so that one mixed design is not getting affected with this element during concreting. Those things should be segregated in which manner, in a most economic but safe way. Those things we should understand. Water storage tank. This water, what we are using during batching, in the batching plant, what should be the right temperature of this water? How that storage tank capacity should be designed. Then batching plant shall be equipped with water chiller and ice dispenser to produce concrete with temperature not exceeding 32 degrees centigrade during hot weather. So as I was discussing that in some places in our country, the temperature goes up to 45, 50 degrees centigrade, but we are using the water during concrete mix preparation in a batching plant, which is having much higher than 32-degree temperature. How does it affect the slump property? How does it affect the workability of the concrete when you are pouring at site? These things we should be very careful. We should know that there are proper British codes, American codes, and I'm sure Indian codes are also there to correlate how these things should be taken care of in a batching plant. Now, batching plant should be equipped with proper storage area as per product technical data sheet of admixtures. In some particular cases, suppose I need quick setting of the concrete because I am pouring concrete in a marshy area, continuous my pump is operating for dewatering operation. At that place, I need a particular admixture. So how this admixture should be stored at site and what is the storage temperature, that we should know from the technical data sheet of that mixtures. These are the things which are very important in a batching plant control, and a QA/QC engineer, which is a new stream of civil engineers. Generally, when we started our career, we thought that civil engineers, either they will be seen in drawing office, design office, in a consultant, or they will be seen in the field as a construction engineer. But there are so many departments, so many avenues of civil engineers which have been developed in last 20 or 25 years. I must say that civil engineers can groom themselves as a planning engineer, as a QA/QC engineer, as a HS engineer, as a contract engineer as well. So those are the things which are not in the industry 20, 30 years back, but now it is very much relevant to the industry, and accordingly, we should change our courses so that they become easily employable and an asset to the industry. Every delivery of concrete supplied should be a delivery ticket. Why it should be a delivery ticket? Suppose in one plant I am doing the design of heater foundation. Half kilometer away there is a ready. So 2 or 3 concreting can be done in 3 pieces. And it is going from one batching plants. Some concrete is designed for M30 grade or C30 grade. Another concrete is designed for C40 grade. If we are not using the proper ticket or of this, which should be carried by a driver who is carrying the concrete mix from the batching plant to the construction site, in a concrete mix type of truck, this might be confused. This might be an accidental phenomena that wrong concrete mix is getting delivered to a wrong site. Suppose I have designed the compressor foundation with higher capacity concrete, C40 grade concrete, whereas a simple administrative building in the same compound, in the same area of that industry. The plant is getting also concreted on in the same day. So how we can control the C30 and C40 grade concrete reaches to the site properly, because generally these concretes are getting carried away by the driver who are not qualified. A driver does not know what is C30 or what is C40 grade of concrete. But a QA/QC engineer at site, he knows or she knows very well. So when he finds this delivery ticket, he knows that this concrete is coming from the right plant, batching plant where from I have ordered. So then he will or she will use that concrete in the casting operation. So these are the ways where a batching plant should be properly operated through a QA/QC guys. Functional checks like admixture dispenser, cement dispenser, aggregate hopper flight, water pump, water temperature, these all should be checked periodically in a batching plant by a civil engineer. That is the way we can maintain the philosophy of the designs which we have done in a very nice white color environment inside the office. But while we are doing the same operation in practice at field, temperature is 45 degree, 50 degree centigrade. So if we do not follow these quality practices, we are leading to the wrong destination. So first batch concrete at every day should be tested in a batching plant to ensure the slump and temperature of the concrete is satisfactory. Concrete delivery ticket should be filled with for each truckload of concrete produced and enhanced and handed over to the truck driver. This is what I was explaining you using the ticket format, why the tickets are really required in good industry sites while we are using the batching plants. Now, finally, when these batching plants are produces concrete, how we should test that these concrete cubes are really having the good strength what for the structure is designed. We should know that what is the right Indian standard code. Okay, I have used here BS code because we are using that in this part of the world, but suitably these codes can be replaced with the equivalent IS codes. So these things should be written in the ITP inspection test procedure, based on which code this concrete cube should be tested at site. Now, sampling techniques. As I was telling you that we are doing the design, construction of a compressor foundation. Compressor foundation, if it is a two-stage compressor, maybe very big compressor with gas turbine, maybe we are putting in one day at a site 500 cubic meter of concrete or 1,000 cubic meter of concrete. Then in that case, how will we control the number of samples when you are putting 50 cubic meter of concrete? What should be the number of samples? What is the rate of samples we should test? That because this has a cost impact in the project. This is not considered. You will pay to the contractor how much concrete he has supplied. But if I do not consider the cost of this sample tests and the checks whether my job is done satisfactorily at site, I am not doing the right job as per the project goal to maintain the ISO 9000 series certificates. So to me, it is very important, based on the criticality of the structures, how many samples I will choose. As you can see in this table that we have some criterias, heavy construction, foundations, raft, we can use sample to present within 100 cubic meter of volume, we can take 50 samples because it is heavy construction, it is foundations. But if it is small cantilever constructions or small column construction in a simple building, we can minimize the sampling up to 10, because if you increase it unnecessarily, the project cost will be much more. So there is a guideline based on the importance of the structures. We select the number of samples, how many samples to be tested at site. Now we will jump to the another topic, which is HSE, health safety engineering, which is very important nowadays in construction sites to maintain the steady progress of construction without any accident. Because our basic goal is no accident and no lost time, no harm of people, no damage to the environment, no asset losses. Because if any accident happens, finally we drag down our potential. So wherever we are today, our intention is to move ahead, not to move back or behind. So if we do not maintain health safety and environmental practices in the industry, we are really not doing the right job to our society. So basically, our industry categorization done in two ways, de minimis or non-de minimis. These kind of terminologies, once a civil engineer knows before joining an industry, it becomes very easy for them to project themselves as an environmental engineer in future. What is de minimis? It is very simple. De minimis projects by company HSEIA, Health Safety Environmental Impact Assessment. Definition means projects involving no or minimal impacts. That is de minimis. Whereas non-de minimis projects are those which will have an impact. Therefore, on HSEIA is to be submitted to company for the review and approval. Suppose I am constructing an offshore platform in the middle of the sea. If any damage happens within the plant, offshore platform, if any pipe bursts, generally we say that through the risers, we lift the oil from underground. So if any riser leaks, what is going to happen? The whole oil is going to mix with the water. So this kind of project has a huge impact on the environment, either locally or globally. So when we are starting a project in the conceptual stage, we must understand that which projects are de minimis category, which are having least impact on the environment and society, and which are having higher impact. In a nuclear power plant, if we do not take proper protections, a big catastrophe can happen. We did not forget our Bhopal gas strategy yet, which has happened 40 years back. And even few days back, I have seen few incidents in India where a chlorine plant gas leakage has happened, and people who are walking on the streets, suddenly they became faint and they fell down. So there are so many things which we must analyze before jumping into the industry. What are the basic criteria? So simply, in simplistic term, de minimis means there will be no or minimal damage to present HSE risk, release or carbon emissions, whereas non-de minimis means the project which will have an HSE impact with potential risks of releases to the air, sea or land, which are likely to cause harm to workers, the public, environment, and different countries as well. So in any project, like I have discussed few minutes back, there is a project quality plan. In any project we do in the similar fashion, HSE plan. Now, what are the main contents in an HSE plan that a civil engineer must know? What are the site? These are the contents, site requirements. That particular site, what does it require? Permit to work before and task risk assessment. What are the permits I should take from the authority before going to the work? Task risk assessment. Suppose I am doing a tunneling work, or I am doing a retaining wall and I have to dig the soil to get the proper bearing capacity. I have to dig the soil up to 5 feet, or 3 meter or 4 meter below grade level. So in that case, it is more than a man height. So when I am doing this excavation at site, what are the risks involved to the workers and how we can minimize those risks? This is called risk assessment. These are the basic things an HSE engineers will produce before starting the construction work at site. Without doing this, if we start, we will go back to this phase. We will go back to this particular, one second, this accident or lost time. So there will be huge lost time and the project progress will be hampered. So these are the things which we must consider before starting any project. Now, HSC training requirement and HSC apparatus. What are the HSC apparatus an engineer must know before joining the site? Construction method statements, how we are going to construct. This is a skill of a construction engineer. These are not taught really in engineering colleges. We have done the design of a truss. We know what are the truss elements, what are the boundary conditions in a truss, which to make it determinate structure, not indeterminate. Then section size choice, limiting the deflection, limiting the sway, limiting the maximum stresses, and that's all. That is the boundary conditions. But how to erect that truss, that is the construction method statements. I will go back to this slide. You can see here that 170-meter high structure is getting erected. What should be the capacity of this crane? How long this crane? You can see this capacity of this crane and another crane also, which is lifting the structures of much lesser height. So how we can select this particular crane, that itself is a pure mathematics construction method statement, because this crane hiring cost maybe $5,000 per day. Now I need to calculate for lifting this kind of structures. I might not need this capacity crane from the beginning. I need this crane when the structure erection has attained the height of say 60 meter, 70 meter. So up to 60, 70 meter height, I can hire a crane of lesser capacity like this. So this kind of proper analysis is done generally in this construction method statements, which is very important in HSE plan. Policies and procedures for constructions, road safety, pre-commissioning, demolition, and decommissioning activities, workers' welfare, camp safety, emergency response. If any accident happens at site, how we have to give relief to the workers or the people who are affected. Heat stress, as we were discussing few minutes before, that when we are doing the construction at 50-degree temperature outside, how we should take care of these people who are affected by the heat stress. Here in Middle East, what we are doing during June, July, August, when the temperature goes beyond 50-degree, and the solar radiation temperature, if you add, it might go beyond 60 degrees centigrade. In those cases, what are the precautions we apply? And we don't generally allow the workers to work between 12 to 4. We split the working hours from 6 to 12, and again from say 4 to night at 10. So to avoid this heat, but if anyone is getting attack of heat stress, how we are taking care of those things, that should be the proper HSE plan in a project to avoid loss of life. And key points, human factors. Now in any project, how do we understand that what is the category of severity? How these projects can be categorized as from the safety and definition of serious incidents, severity categories. Either it is a catastrophic severity or severe or critical. So we have categorized it based on the 4 factors: people, assets, environment, and reputation. If any catastrophic things happen, all of us know that few years back, BP, British Petroleum, had faced a huge fine from USA because one of the platforms the offshore platform got fire in the middle of North Sea, and it was a real catastrophic incident, and there was huge loss of marine lives, and the water storage, groundwater storage of nature earth have got disturbed in a big manner. So we generally define the entire project's severity under different categories based on the four factors. So a civil engineer must know these basics before joining the industry. Then it is very easy for him or herself to do this kind of work within 6 months or 1 year after joining the industry in an effective manner. Means they should really contribute to the project. Now we will go to the contract management role, because our topics of today is mainly what are the role of QA/QC, HSE, and contract management. All of us have become a very good calculation master. We know how to calculate stresses, how to calculate the bearing capacity or settlement in a foundation. But end of the day, if when we are working in a company, if we are not paid properly, what will be our mental status? Please tell me, sir and madam, what will be our mental status? We will simply stop our working and we will be demoralized and we will not join. As simple as that. So in a project contract, EPC contract, engineering, procurement, construction contract, when a contractor is working, how he will formulate the cash flow strategy in a project, these things should be properly written in a contract. On the other hand, who are end user or client, when he is floating a project to the contractors, either it is a national contract or it is a global national tender or a global tender, client should keep proper provisions so that they are also not cheated from the contractor, so that contractor cannot run away in between the construction phase. So there are so many things in a project contract management before floating a tender till award of the contract, and after contract award we said contract administration. That is another topic which I have developed a course, contract management and contract administration. I taught UK universities 10 years back. Sir, please remember, 10 years back. So Europe has imbibed this kind of courses within the academic institutions so that their engineer become more practical when they join the industry. So how to formulate a project strategy? What is the pre-qualification process when we are selecting the bidders? Then obtaining tenders. There are two parts of the tender, technical part and commercial part. What should be the contract? What should be the content in a technical part? What should be content in the commercial part? What is the terminology, tender bulletin, technical queries, tender clarifications? How to evaluate a tender and negotiate with these contractors, and finally award the contract. These are the basic steps in a contract management course. There are some specialties which I can always teach to the students as a separate credit course, but these are the basics which a civil engineer should know in a contract management. Pre-qualification documents. What is the pre-qualification process? Qualification documents comprising letter of invitation. This is the letter of invitation to the bidders. Information about pre-qualification procedure. What are the information you are looking from a bidder during his bid submission? Suppose you are building a chlorine plant. Definitely you will not welcome a bidder there who has an experience of construction of swimming pool or multi-story buildings. So what are the informations you are really looking from a bidder who is expert in a chlorine plant construction? Project information, minimum information of a project, pre-qualification application. These are the things which we must know as a contract engineer, how to prepare a pre-qualification documents for inviting the bidders. Issue pre-qualification documents, questionnaires, request pre-qualification documents and organization and the structure, experience in the intended type of work in the region. Did that contractor build similar type of project in the region or outside it? What are the resources? What are the managerial capacities, technical, labor, plant resources, and what is the financial statement of that particular bidder last 10 years? So this we say as a due diligence checking, means whether that contractor is able to perform the job, like your college is doing the entrance examinations before taking any student, whether he or she is eligible to grasp the subjects which you are teaching in your course. Similarly, when we are inviting a contractor in any project, we must do the proper due diligence. We cannot take entrance exams, but these are the basic things which we do in the same manner to eliminate the unqualified bidders. So what are the basic criteria to eliminate the unqualified bidders and streamline the effective contractors for a project? These are the things which we must know in the contract management course. Current contract commitments, litigation history. There are so many things we must know in a contract management course. Now, preparing tender documents. When this tender document is ready to float to the bidders, letter of invitation to tender, instruction to, we say it ITT, instruction to tenderers. What are the instruction should be available? General and special conditions of contract. Suppose in a state, in a particular state, India is having so many states, there might be a particular law in a particular state which is not applicable in another state. So what are the general conditions of the contract? What is the special conditions of contract that we must tell to the contractor? The form of tender, drawings and specifications and scope of work. We are discussing these things, that design basis and the specification, structural, civil structural design basis, what it should contain. If the bidder does not obey this, what is the minimum grade of structural steel? What is the grade of minimum reinforcing steel? What is the minimum grade of cement, or what is the specification for the coarse aggregates you are trying to follow in your project? Those things should be very clear in the specifications and scope of work documented. Finally, bill of quantities, planning schedule, and additional information. So planning schedule is very important, that you want to build your project in 2 months time or 2 years time. That should be very specific. Proper logic should be there, why you want it within that particular schedule. So these are the things we are hearing now, that in few states in India, they are building the special hospitals for the COVID patients in 7 days, 10 days time. So how they are doing it, how planned they are, please understand that they are the master planners, otherwise they cannot do these jobs. So when we give the basic sense of this planning scheduling to a civil engineer before joining the industry, they will be much more productive when they join the industry. Now, how to do the technical bid evaluation in a tender? You see, in particular evaluation parameters, what should be? I'm just showing you only one aspect, that there are 3 bidders, you can see it, and we are just discussing here in the evaluation parameter, engineering skill. This engineering skill, is it done by these bidders, Dragados, Petrofac, or CCIC, or they are giving it to the subcontractor? You can see under this bidder, he is using this subcontractor. So we do not know what is the equation, commercial equation between this main contractor and this subcontractor. So this main contractor is not depending on its own resources of engineering. He is depending on others' resources on engineering part of any project. Whereas we can see here, Petrofac, the main contractor, they have their own design team. So in this case, definitely I will prefer this contractor, because they are self-dependent on their own engineering resources, like Larsen and Toubro in our country. So these are the ways of what should be the criteria in a technical bid evaluation when we receive a contractor from the bidders. Those are the very important factor, and my contract management course covers all these things in detail. When they come out of this course, they will be easily, appreciated by any industry immediately after joining. Now, I will just highlight here few slides and then I will conclude my speech. What are the new challenges in the industry and why do we need this kind of collaboration? So far, we have spoken with this additional knowledge from the industry to the academics. But as I started my speech today, that we civil engineers are the experts to build bridges between industry and academics. You are all experts in academics. Sir, please learn, please understand that there are some challenges in the industry which you are the best people in our country to resolve. What are those new challenges in the industry? I have designed a plant 30 years design life. Now, this plant, after 30 years, I cannot make it scrap. Okay, I have designed it, but after 30 years, I cannot make it scrap. In our country, there are bridges which were built by Britishers 200 years ago, right? And those bridges are still functioning. When I drive from Bangalore to Uti, I cross from Coimbatore to Uti. I have my house in Uti. So when I drive from Coimbatore, I cross so many bridges, steel bridges, arch type bridges, which are built during British era. Still, those are surviving. But where are the drawings, sir? How do you know what is the strength of that bridge? How do you know? How do you ensure that tomorrow there will not be any accident when you are passing at 60 kilometers per hour speed in your car over the bridges? How do you ensure? Where no drawing is available to reassess existing capacity. Now, these are the challenges in India. I understand that Indian government has already given huge tasks to few IITs to revalidate the strength of few bridges in India. I have good connections with IIT Guwahati and IIT Kanpur. I know few IITs are working on that. We cannot suddenly destroy those bridges because it has a cost impact, and we cannot discontinue the communication also because these bridges are between one part of land and another part of land. So how we can evaluate the existing strength of structures in an old plant, which is a steel plant in 30, 40 years old, 50 years old, the structures were built. How do you know that tomorrow there will not be huge deformation of structures or settlement of foundation? There is a technology, sir, which we are using now. It is called, so in these cases, we don't have any record of the old drawings of the plants. If it is a new plant, we do the survey. We know what are the structural members, what is the foundation size. We can calculate the strength and we know what is the longevity of these structures. But if it is a 50 years old structure, in my city, Calcutta, this Howrah Bridge is more than 200 years old, but it is still today so stout, strong, and beautiful. You know, how we can maintain the structural integrity. These are the real challenges of civil engineers nowadays, where gentlemen and gentlewomen from these academics would be a big boon to industrialists like us to assess the strength. How are we doing it at present? I will just give a small glimpse. You see that laser scanned clouds conversion, how we are getting the data of these structures by using this simple instrument. This is a scanner. This laser scanner is with a high speed revolving 360-degree revolving camera. This camera is placed on the top of this trolley and moved in between the gaps in a congested plant and hazardous area. So this camera will be able to produce the snapshots in this manner. So it will take the laser scanned data of pipe racks. I have given it because this is a this is the project which I did in Abu Dhabi 5 years before. I introduced in an oil plant here. So this oil plant was more than 40 years old, but still there are oils, so they cannot make this plant scrap, but they have to reassess the strength. So we used their pod files, we used these scanners to get preliminary data, laser scanned clouds conversion to primitive and intelligent 3D structural analysis model. So once we can get the exact structural sizes here, and then it is easy for us to model it under StatPro. So you see, this is the cloud primitive. This is an offshore platform, which is also very old. This is a primitive modeling. This is the first step from the cloud data. So this is the way we prepare the primitive model, and then we use these pod files using a software called ProSteel under research engineers, or which is bought by Bentley organization now. You know, the StatPro is a property of Bentley now. So these deep down build projects in oil and gas plants for sustainable production, and as I told you, that other congested industrial plant conditions or bridges or heritage structures or buildings. So first we do this survey with this scanner, then we prepare the pod files, and from this raw laser scan data, we prepare a primitive model. Primitive model means what is the shape of these structures? Is it circular? We can see here this walkway platform is with a tubular sections. It is not I section or it is not channel section. Whereas in this particular place, it is not tubular sections, it is either channel or angle or I sections. So using software called ProSteel, we get primitive models. Then by one after another, it is a tedious job to setting the library of all structural steel members, Japanese sections, American sections, or British sections. At least we will have some idea from one or two local surveys at what kind of sections used in this plant. So those sections we will put as a library, and then from the primitive modeling we will prepare finally intelligent modeling like this, where we will know each and every, these are the pre-model snaps, final conversion, each and every member sizes. And then finally the food is ready for the structural analysis engineers, and we go to this step of 3D structural model, and we can do the analysis with the proper forces from the pipe racks on this particular structure, from the pipe load, then environmental load, wind load, live loads, walkways, and the other applicable loads on these structures. We get the analysis results. We know what are the actual stresses on the structures, considering some strength decay, or you can say that any structure has less potential carrying capacity with the age factor, like concrete has an age factor. Steel also, steel stress capacities has also gets reduced due to the fatigue. We know that. So we allow reasonably reduced permissible stress, and then check that what is the actual strength of this kind of structures now, and then where I have to reinforce. If I have to reinforce, I can weld one plate on the flanges or at the bottom of beam here, or I can strengthen one connection here by using higher category bolts. So these are the ways we are conquering the present challenges in the industry. There are many more challenges which we can discuss, in further sessions. But I thought to give you a glimpse to all the attendees here today that what are the industrial challenges to us. And believe me, We must work hand in hand together to build our country in a much more stronger manner, and we all should be proud in that particular operation to make our country more stronger and most powerful in this world. Thank you so much, Mr. Anup, Dr. Rajesh, and all the attendees. I conclude my speech by this sentence, and the last slide, you can note down my details here. Thank you so much, sir. I am just stopping the sharing with your permission.
Thank you, sir. Thank you very much. That was very thought-provoking presentation. What you said was really inspirational. That academia and industry, we should be going hand in hand, sir. Yes. So that is why we are having so much gap between industry and academics that we are dealing with.